Welcome back to our online lessons. So in today's lesson we're going to have a look at rectilinear motion, and the part we're going to look at is the antiderivatives. So in previous lessons, or in year 11, you had a look at if you're given displacement, you want to find velocity, you have to differentiate, and if you're given velocity, you want to find the acceleration, you have to differentiate, which is given by the arrows at the top. And now what we're going to basically trying to do is you'll be given the acceleration and you will have to find the velocity. So in this case what you need to do is you have to anti-differentiate or integrate. And similarly, if you're given the velocity and you want to find the displacement, you again have to anti-differentiate. But bear in mind, when you anti-differentiate, you will have the constant, the plus c, that you need to find. And to find those, you will be given some initial conditions. So let's have a look at our first example for today. Given a is 5t, 5 take 2t, and initially v equals 3 meter per second. Now the v equals 3 meter per second, that's called the initial condition. So you're given v is 3 when time is 0. Find an expression for the velocity of the function. So velocity will be integral of acceleration from what we've seen above. Integral of 5 is 5t, and integral of 2t is t squared plus c. Now to find c, we use the initial condition given up. So initially means when time is 0, v is 3. So we substitute t is 0, v 3, and then we work out the value of c, which gives us c equals 3. So replace t by 0, v by 3, and then you can work out the value of c, which is 3. Hence v is 5t take t squared plus 3. Let's move on to our next example. So v equals 6t squared take 10t plus 15. Find an expression for the displacement. Now again, you're given v, you want to find x, we have to anti-differentiate, and we're given some initial conditions to find c. When x is 10, when t is 1, x is 10. So x is integral of velocity. So we have integral of 6t squared take 10t plus 15, which gives us 2t cubed take 5t squared plus 15t plus c. When t is 1, x is 10. Substitute, and then we solve for c. So c equals -2, and that is our displacement function. Next example. A particle moves in a straight line such that its acceleration at time t seconds is given by a equal 2t minus 3 to the cube meter per second squared. State the value of the acceleration when t is 3. So this is quite simple. You basically have to sub t equals 3 in the given equation, and I will give you 27, and don't forget the units. It's meter per second squared. Next, the velocity function if v equals 9/8 when t equals 2. Now to find the velocity function, we anti-differentiate a. So we anti-differentiate 2t minus 3 to the cube, which is 2t minus 3 to the power 4, divide by the new power, and then divide by derivative of bracket. And then don't forget the constant term plus c, and use the initial condition. V is 9/8 when t is 2. We sub those values. So to find c, use the initial conditions, replace v by 9/8 and t by 2, and that will give you c equal 1. Hence v equal 2t minus 3 to the power 4 over 8 plus 1. Now try exercise 3c. Thank you.